This is a video from section 3.6. Let y equal log base b of x, where b is greater than 0 and b does not equal 1. And so what that says is b to the y equals x. Differentiate both sides with respect to x, so we get the derivative of b to the y with respect to x is the same as the derivative of x with respect to x. Now, the derivative of b to the y with respect to x is b to the y times natural log of b times dy dx. It's chain rule. The derivative of x with respect to x is 1. So b to the y times natural log of b times dy dx is the same as 1. So dy dx is 1 over b to the y times natural log of b, but b to the y is the same as x, and so therefore dy dx is 1 over x times natural log of b. And what that says is it's the derivative of log base b of x with respect to x is 1 over x times natural log of b. Now let's look at a special case. Now, natural log of x is log base e of x, okay? And natural log of b is the same as 1. And so therefore the derivative of natural log of x with respect to x is equal to 1 over x times natural log of e. And so therefore the derivative of natural log of x with respect to x is equal to 1 over x, because remember natural log of e is 1. Okay, and we're going to need that. Now, the directions say to differentiate the function. And what I want to do is look at problem number 2. Suppose g of t is natural log of 3 plus t squared. The inside function is, we'll call it h of t, is 3 plus t squared, and the outside function which we'll call f of t, is equal to natural log of t. But remember, f prime of t is equal to 1 over t. And so when we want g prime of t, we're going to take the derivative of the outside function, but we're going to evaluate it at the inside function first, okay? So we're going to get 1 over, and then I'm going to replace t with 3 plus t squared. So we get 1 over 3 plus t squared, and then what I do is I'm going to multiply by the derivative of the inside function, again with respect to t. That's chain rule. And so this is 1 over 3 plus t squared times 2t. And so therefore, g prime of t is 2t divided by 3 plus t squared. And that's number 2. If we take a look at number 3, suppose f of x is equal to natural log of x squared plus 3x plus 5. Now, if we look at the outside function, we'll call it h of x is equal to natural log of x. The inside function we'll call g of x is equal to the argument of the natural log. So in this case, it's x squared plus 3x plus 5. The derivative of the outside function is 1 over x. And so I'm going to take 1 over x and evaluate it at the inside function. So in other words, I'm going to replace x with x squared plus 3x plus 5. So when I calculate this derivative, I get 1 over x squared plus 3x plus 5. But we have to multiply by the derivative of the inside function. Once again, with respect to x. So this is 1 over x squared plus 3x plus 5. And I'm going to multiply by 2x plus 3. Okay? And so therefore, f prime of x is 2x plus 3 divided by x squared plus 3x plus 5. That's number 3. I want to take a look at number 4. Suppose f of x is equal to x times natural log of x minus x. Now, to calculate the derivative of x times natural log of x, we have to apply the product rule. Okay? So when I want f prime of x, I write the first function, which is x, but I multiply by the derivative of the second function. And then I differentiate with respect to x, and then I'm going to write down natural log of x, that's the second function, and I'm going to multiply by the derivative of the first function. And then I subtract the derivative of x with respect to x, so essentially I'm subtracting 1. And so here this is x times 1 over x plus natural log of x times 1 minus 1. So this is 1 plus ln of x minus 1. The 1's cancel. And so therefore, f prime of x is equal to natural log of x. That's number 4. Let's take a look at number 5. Suppose f of x is equal to sine of the natural log of x. Now, I want to take and find f prime of x. The outside function, so I'm going to once again write that down. The outside function here we'll call h of x is equal to sine x. The inside function that's going to be the argument of the sine, which is natural log of x. So g of x is natural log of x. So let's give ourselves room, and I want f prime of x. The derivative of the sine is cosine. So I'm going to take cosine and evaluate that at the inside function, which in this case is natural log of x. But I'm going to multiply by the derivative of the inside function with respect to x. So I'm going to multiply by the derivative of natural log of x with respect to x. And so f prime of x is cosine of natural log of x times 1 over x. And then if we write this a little bit simpler, we can say f prime of x is cosine of natural log of x divided by x. That's number 5. I want to take a look at number 6. Suppose f of x is natural log of sine squared x. The outside function we'll call it h of x is natural log of x. The inside function we'll say is g of x is sine squared x. So I like to keep track of what's inside, what's outside, and I do like to think of this as like peeling an onion. I like to work from the outside in. So if I want f prime of x, the derivative of natural log of x is 1 over x. But remember, we're going to evaluate the derivative at the inside function. So I'm going to replace x with sine squared x. So I get 1 over sine squared x. It's chain rule the whole time. But then I'm going to multiply by the derivative of the inside function, which is the derivative of sine squared x with respect to x. And so f prime of x is 1 over sine squared x times 2 sine x times cosine x. So I had to apply the chain rule just to take the derivative of sine squared x. Now, this says f prime of x is 2 sine x cosine x divided by sine x times sine x. And sine x's cancel, and we can say f prime of x is equal to 2 cotangent x. Cosine x over sine x is cotangent x. And that is number 6. If we take a look at number 8, so on number 8, we have y equals 1 over natural log of x. And if you don't mind, I'm going to write this as natural log of x raised to the negative 1. And I want to find dy dx. So here I get negative 1 times natural log of x to the negative 2, right? So essentially, I'm taking the derivative of x to the negative 1, but I'm going to evaluate it at natural log of x. So it's a power rule. And then I'm going to multiply by the derivative of the inside function. But the inside function is the natural log of x. So I'm multiplying by the derivative of natural log of x with respect to x. And so this is negative 1 over natural log of x to the second times 1 over x. So if I just simplify this a little bit, I get dy dx is negative 1 over x times natural log of x to the second. That's number 8. If we take a look at number 9, suppose g of x is equal to natural log of, let's write it this way. So natural log of xe to the negative 2x. There are other ways to attack this, but I'm going to teach this particular problem this way. So we're going to apply the chain rule. So if I want g prime of x, remember that the outside function is, we'll call it f of x is natural log of x. Okay? So the outside is f of x equals natural log of x. If I differentiate, I get 1 over x, but I'm going to evaluate it at the inside function, which is the argument of the natural log. So in other words, I'm going to get 1 over the inside function, which is x e to the negative 2x. But I'm going to multiply by the derivative of the inside function. So it's an application of the chain rule. So g prime of x is 1 over x e to the negative 2x times. So I'm going to write down the first function, and then I'm going to take the derivative of e to the negative 2x. But that's e to the negative 2x times the derivative of negative 2x with respect to x. And so that's times negative 2. I'm going to go plus e to the negative 2x times the derivative of x with respect to x, which is just 1. And then what I'm going to do is I'm going to factor out an e to the negative 2x. So I get 1 over x e to the negative 2x times e to the negative 2x. Okay, notice the e to the negative 2x, that's common to both. And I'm going to multiply by 1 minus 2x. Okay, there's a 1 here. There's a minus 2x left over here. But these guys cancel. Okay? And so therefore, g prime of x is 1 over x times 1 minus 2x, which is equal to 1 over x minus 2. There's another way you can attack that that I will point out to you. Now, g of x is equal to natural log of x e to the negative 2x. But this is natural log of x plus natural log of e to the negative 2x. And keep in mind something. E to the negative 2x is greater than 0. So x cannot be negative. It's not possible. X would have to be positive by force as well. Okay? Now, this is equal to natural log of x plus negative 2x times natural log of e. But remember that natural log of e is equal to 1. And so this is natural log of x minus 2x. So I do a little bit of simplifying first, and then I find g prime of x. And so if I come over here, I can say g prime of x is equal to 1 over x minus 2. So I simplify the natural log first, and then take its derivative. And that is legal. And that's number 9. If we take a look at number 11, suppose f of t is natural log of t to the second times sine of t. So there's a little bit of product rule here, but within the product rule, we apply the chain rule. So f prime of t, we're going to write down the first function, which is natural log of t to the second, and we're going to multiply by the derivative of sine t with respect to t. And then I'm going to add the second function times the derivative of natural log of t squared with respect to t. Now, this is natural log of t to the second times, now the derivative of sine t with respect to t is cosine of t. Okay. And then I'm going to write sine of t times. Now, to differentiate natural log of t squared, we have to apply the chain rule. So this is 2 times natural log of t times the derivative of natural log of t, which is 1 over t. But I'm going to factor a natural log of t out. And when I do that, I get the following. I get natural log of t times natural log of t times cosine of t plus 2 over t sine of t. And I would talk to your instructor about how far your instructor wants you to simplify this here. So it's just going to depend. Let's take a look at 13. Suppose y equals, we get log with base 8 of x squared plus 3x. Now, I would recommend doing this. I would rewrite this as y equals natural log of x squared plus 3x divided by natural log of 8. So this is basically a change of basis, or a change of base problem, okay? It's much easier to take the derivative of natural logs than it is when the base is something other than e. So if I want dy dx, I'm going to pull the 1 over natural log of 8 out. And I'm going to multiply this by the following. So we're going to take the derivative of this numerator here, and we get 1 over x squared plus 3x times the derivative of this inside function, which is the derivative of x squared plus 3x with respect to x. So this is 1 over natural log of 8 times the derivative of x squared is 2x. The derivative of 3x, again with respect to x, is 3. And we're dividing by x squared plus 3x. And that's how we find dy dx. So the key is performing a change of base before you attack this problem. That was number 13. If we take a look at 15, suppose f of s is natural log of s, and we want f prime of s. Now, the outside function and the inside function match. And so we're going to take 1 over natural log of s, and we're going to multiply. Remember, we're peeling an onion. We're going to multiply by the derivative of the inside function. They all work very similar in that way. And so this is 1 over natural log of s times 1 over s. And so therefore, f prime of s is 1 over s times natural log of s. That was 15. And that's a good stopping point. That'll conclude this video for section 3.6. And we worked on the following problems. We worked on 2, 3, 4, 5, 6, 8, 9, 11, 13, and 15. Thank you.